In this video, I'll explain what machine learning actually means in agriculture and environmental science, how it is used differently in industry and academia, and which programming language makes sense depending on your career path. My name is Meshak, and I'm a data scientist researching the application of machine learning in agriculture and environment. So let's start with the basics. Machine learning is a way for computers to learn patterns from data and make predictions without any fixed rule. Instead of manually programming decisions like when to irrigate, a model can learn from historical weather, soil, and crop data to make better decisions automatically. In agriculture, machine learning can predict crop yield, it can detect crop diseases from images, and optimize fertilizer and water use. And in environmental science, it monitors air and water quality and track land use change from satellites. Much more, it can even predict and quantify greenhouse gas emissions, such as N2O, CO2, and several others. So at its core, machine learning turns massive data sets into usable decisions. In industry, machine learning drives precision agriculture. Farms no longer treat entire fields the same way. Models can analyze data from satellites, drones, sensors, and yield monitors to make zone level or plant level decisions. Key applications include yield forecasting for better planning, disease and pest detection using computer vision, precision agriculture, and fertilization to reduce waste. This system aims for one thing: measurable return on investment, higher yields, lower input costs, and reliable performance. The biggest challenges are messy farm data, limited connectivity, hardware cost, and usability for non-technical users. That is why industry is moving towards simple AI crop advisors and autonomous equipment that hide complexity behind clear recommendations. Environmental industry applications focus on real-time decision support. Cities and utilities use machine learning to monitor air and water quality, detect pollution early, and respond to floods or drought. Common uses include pollution forecasting, water quality monitoring, early warning system for environmental hazards, and many more. These systems must run continuously, they must be reliable, and be transparent enough for regulators to trust. Accuracy and stability matter more than the experimentation. In academia, machine learning is used very differently. Here, the goal is understanding, not just prediction. So, researchers use machine learning to study soil health, crop response to climate, carbon sequestration, and interactions between management and ecosystems. Key focuses include explaining mechanisms, not just outcomes, designing efficient feed experiments, integrating ML with crop and ecosystem models, ensuring reproducibility and transparency. In research, models must be explainable, defensible, and publishable. Environmental research relies heavily on machine learning to analyze complex data. Researchers study climate trends, extreme events, land use change, biodiversity, and ecosystem dynamics using satellite data and sensor networks. So, the important priorities are detecting long term trends, understanding causal drivers, publishing open and reproducible methods. In academia, clarity and scientific contribution matter more than operational deployment. So, the difference is simple: industry prioritizes deployment, scalability, and return on investment. Academia prioritizes rigor, explanation, and advancing knowledge. So, both use machine learning, but for different reasons. That difference shapes the tool you choose. In industry, Python dominates. It supports the full pipeline from data processing to model deployment using libraries like scikit-learn, PyTorch, and TensorFlow. It integrates easily with cloud systems and production environments. In academia, especially ecology and agronomy, R remains very strong. R excels at statistics, visualization, and publication quality analysis using tools like ggplot2, dplyr, and tidy models. The honest takeaway is that Python is best for production and large-scale ML system, and R is excellent for statistical analysis and scientific reporting. So many researchers today they use both. If you want industry roles, start with Python and learn it deeply. If you want academic research, start with R. If it is the standard in your field, then add Python for modern machine learning. The language matters less than understanding data, uncertainty, and modeling principles. So, strong practitioners are bilingual. Personally, I can program in both. I can program in Python and I can program in R at the same time. So, if you want to grow, pick a real problem like crop yield prediction or environmental monitoring and build a complete project. However, on this channel, Learn with Meshach, I break down real machine learning problems in agriculture and environmental science step by step. So if that sounds useful, like the video, subscribe, and turn on your notification bell so you can get updated whenever I upload new videos. Thanks for watching.